A project rarely fails overnight. It suffers a quiet demise from scope creep. Uncontrolled additions bloat the plan, the budget drains, and the schedule collapses. To prevent this, project controllers use a process called collect requirements. This is the systematic work of determining, documenting, and managing what stakeholders actually need to meet the project's objectives. If you get these requirements wrong from the start, every downstream calculation fails. Your K3 cost estimates will be based on guesswork, and your K4 schedule planning will sequence the wrong activities entirely. For a project control professional apprentice, this is a critical point of failure. Submitting an endpoint assessment portfolio without properly documented requirements means you cannot prove you know how to define a scope. Gathering requirements is an active, defensive investigation. It is how you lock down your K2 scope baseline before the project even begins. Every investigation starts with the existing case files. In project management, these are your project inputs. You begin with the project charter. This document provides your high-level boundaries and gives you an initial list of key stakeholders to interview. Next, you cross-reference those stakeholder desires with the business case. This ensures that every requirement you gather actually aligns with the organization's strategic value and return on investment, filtering out irrelevant personal preferences. These initial inputs form your constitutional boundaries. They prevent the project team from chasing unauthorized or out-of-scope demands. With the boundaries set, you move to direct data gathering. You might use one-on-one interviews to elicit confidential information or convene focus groups to gauge the expectations of pre-qualified stakeholders in an interactive setting. As you can see in this image of standardized bubble sheets, sometimes you need to quickly accumulate data from a massive, geographically dispersed audience. That is exactly when you deploy questionnaires and surveys for rapid statistical analysis. When stakeholders have trouble articulating exactly what they need, you conduct a stakeout. Through observation or job shadowing, you watch them perform their daily tasks to uncover hidden requirements they might have forgotten to mention. Inevitably, stakeholders will disagree. When that happens, you use decision-making techniques to force a resolution, whether that means requiring unanimity, settling for a simple majority, or using a plurality where the largest block decides. Mastering these specific gathering tools allows a PCP learner to generate concrete evidence of S1 stakeholder engagement for their endpoint assessment. All of those interviews and surveys will leave you with a massive pile of raw, chaotic data. You have to structure it into logical models before it becomes useful. Look at this visual breakdown of colorful sticky notes. This is an affinity diagram, a tool used to take large numbers of individual brainstorming ideas and classify them into distinct, reviewable groups. You can also map out boundaries using this chart, known as a context diagram. It visually depicts how internal and external actors interact directly with the central business system by showing the exact flow of data. To get concrete feedback early on, you can build prototypes or use storyboarding. These methods let stakeholders experiment with a physical or digital model of the final product before the actual build phase starts. Structuring raw requirement data into visual models addresses the data management K12 and K13 competencies required for the examiner's review. Once the evidence is structured and verified, it is time to write up the official requirements documentation. This details exactly how individual requirements meet the business need. This document categorizes everything. It separates the business requirements, the high-level strategic needs of the organization, from the stakeholder requirements, which are the specific needs of a particular user group. It also details the solution itself. Functional requirements describe the specific behaviors and processes the product must execute, while non-functional requirements outline environmental conditions like security, reliability, and performance. Without this strict categorization, undocumented requirements act as mere rumors. Meticulous documentation is what forms an actionable, legally binding scope baseline. The central mechanism for maintaining scope control is the most important output of this entire investigation, the Requirements Traceability Matrix, or RTM. The RTM is a master grid linking every requirement from its origin, through design and testing, directly to the deliverable that satisfies it. It tracks critical attributes across the project lifecycle, including unique identifiers, owners, and status dates. For a PCP apprentice heading into their endpoint assessment, the RTM serves as the primary evidence for S3 scope control and K13 data traceability. Mastering the project inputs, interrogation tools, and the RTM builds the integrated project control system required for a successful endpoint assessment submission.